So we want to find the exact length of this curve. It's y equal 3 plus 1/2 cos 2x. We want that from 0 to 1. So here is the curve of our hyperbolic cosine, and we're interested in this little segment that you see here in red between 0 and 1, finding the length of that. So using our formula for the length of a curve, we know that length, we're going to integrate between 0 and 1. We have the square root of 1 plus, we need the derivative of this. The derivative of 3 is 0. The derivative of the hyperbolic cosine is the hyperbolic sine, but we have 2x, so the chain rule will apply. So it's going to end up being the hyperbolic sine of 2x, and then we need that derivative squared dx, because we had this 1/2 out in front, but we generate a 2 from the chain rule, and those will cancel. So now we need to evaluate this, and we would have the length of that curve between 0 and 1. So how are we going to go about evaluating this? Well, I don't know how to evaluate it in its present form, but I do know that 1 plus the hyperbolic sine squared of an angle equals the hyperbolic cosine squared. And so that was going to be the square root of the hyperbolic cosine of 2x. I'll just do it like this, squared dx. So nicely the squared and the square root will cancel. So then I just need to integrate the hyperbolic cosine, and the integral of that is hyperbolic sine, but I have a 2x. So I'm going to need a 1/2 and the hyperbolic sine of 2x, so that when I do the chain rule, it generate that would cancel. And that needs to be evaluated from 0 to 1. So now I can go ahead and do that evaluation. So it's 1/2 hyperbolic sine of 2, putting in the upper limit, minus, and then hyperbolic sine of 0. So refreshing our memories of this, the actual answer to the problem is going to end up being 1/2 hyperbolic sine then of 2, because this is 0. But what does hyperbolic sine mean? By definition, the hyperbolic sine of, we'll go ahead and do it for x, is going to be e to the x minus e to the negative x over 2. And remember, hyperbolic cosine is just like this, but has a plus sign in the middle. So if we put in a 0 here and here, we have e to the 0, which is 1, minus e to the 0, which is 1. 1 minus 1 is 0. So this hyperbolic sine is 0. Had this been hyperbolic cosine, it would have been 1. So we need to check that out. And so this is our solution in exact form, and we actually could work this with a 2 here and here and put it in a calculator if we needed a decimal approximate.